All right, guys, it's Ripley. Welcome back. You have reached the summit. In an introductory statistics course, this is it. We're going to start testing hypotheses or testing claims. And these claims, what we're going to go over is so cool and so useful, and it really builds the foundation for all of statistical theory and statistics used by researchers. Let me explain this as simply as I can. If you take a die and you roll it and a 6 pops up, is anybody surprised? The answer is probably no. If I take a die and I roll it again and another 6 pops up, is that unusual? Are you surprised? No. But what if I take that same die and I roll it, say, 10 times, and all 10 times you get a 6. Now your spidey sense is tingling, isn't it? Something ain't right. Now, is it possible that you could take a die and roll it 10 times and get all 10 rolls to be 6s? Of course, it's possible. But is it probable? Well, I mean, let's just look at the probability of it. The probability of 10 6s, right? They're independent rolls, so it's 1/6 raised to the 10th, or 1/6 to the 10th, right? Which is, I'm going to throw it on my calculator, divided by 10 to the, 6 to the 10. I'm going to screw that up. 6 to the 10, and guess what? It's 0.000000000 1, 2, 3, 4, 5, 6, 7 165. That is highly improbable, okay? Now, what does that mean? It means that since the probability of this roll is so low as to almost be 0, we have to conclude that something is wrong with the die. All right? Now, this idea, while dramatic and a bit of hyperbole was used to demonstrate, is exactly the idea behind testing a claim using statistics. Now, just like we build confidence intervals around proportions, around mu, and around sigma squared, or sigma, right? We're going to do the same thing, only we're going to test claims around proportions, means, variances, and standard deviations. Really, what we're most concerned with is these two guys. And the hard part is to sort of get your brain wrapped around which method that you're going to use, because there are multiple methods in doing this. But some are more confusing than others. For some people, certain methods work really, really well. All right? And I'm going to go through all of the methods. By the time everything is said and done, we're going to talk about all of the methods, all of the statistics that we use, all of the formulas that we use. Okay? So it's official. Welcome to the party. So the first thing that we need to be able to do if we're going to test hypotheses is we have to learn how to write hypotheses. Okay, so we got to learn what that entails. Now, there are two kinds of hypotheses. There's something called the null hypothesis, and then I'll just abbreviate that. And this is written, we're mathematicians, so we're lazy and we need shorthand. And there's something called, this is written as H sub 0. And then you'll see this written as the alternative hypothesis, lazy today. And sometimes you'll see this written as H sub A, but usually you'll see it written as H sub 1. All right? Now, there are only two hypotheses in hypothesis testing. Now, I'm going to show you this. The best way to do these is to demonstrate. The one thing that's the most important that you wrap your brain around is the fact that the null hypothesis always contains the equality. If it's got an equal sign in it, it goes with the null hypothesis. So the null hypothesis says, I'm going to have an equal sign in this. Now, I'm going to read you a couple statements, and then we will develop the null and the alternative hypothesis for them, okay? This is a claim. We're going to test a claim, and we're going to write the hypothesis for this. 3/4 of all adults use the internet. That's my claim. So we're going to write up the claim, and we're going to do 3/4 of adults. I don't know why I'm slashing my fractions like that. It's silly. Adults use the internet. All right? Now, I don't know if it's accurate or not. I don't. To be honest with you, I don't really care at this point. 3/4 of adults use the internet. Now, the first thing that we want to talk about here is, what are we testing? Are we testing let me change colors. Are we testing the mean? Are we testing a proportion, or are we testing a variance? That's the most important thing. And really, that's all that you have to worry about, is which of those three things are we testing? Well, look at it. It's 3/4 of adults use the internet. Think of this as 75%. Think of that as 0.75. So what we're doing is we're doing a test on the parameter for proportion. So watch this. All I do is I'm going to write up my null hypothesis and my alternative hypothesis, and here they come. My null hypothesis is that the parameter P equals 0.75. Now notice, it says, in other words, basically this statement right here can be distilled down to the population proportion of adults who use the internet is 0.75. Now, notice that the null hypothesis contains the equality. It always does, and it always has to. The alternative hypothesis, well, what is the complement of P equaling 0.75? Well, it's simple. It's P doesn't equal 0.75. That's it. Those are my hypotheses. Either this is true or this is true. Statistics doesn't concern itself with, well, what about it could be 0.75 or it could be 0.8 or maybe 0.67. No, it's either 0.75 or it ain't 0.75 as far as us testing this claim is concerned. All right? Now, let me read you another one. All right? The average amount of garbage that households use, let's write this up. I'm going to get back to my black. Back in black. Sorry. Average garbage. Wow. Sorry. Let's try this again. Average monthly garbage. I'm not going to write that in. Garbage households use. Households use is less than 30 pounds a month. Month? Yeah, what the heck. Less than, or maybe a week. Who knows? Doesn't matter. Is less than 30 pounds. All right, that's my claim. Somebody comes up, yeah, the average household burns through 30 pounds garbage a week, a month, a year. We know that's probably not true. Okay, now we're going to test that claim. We're going to go out and we're going to say, okay, well, let's see what that really entails. All right, so I got my null hypothesis and my alternative hypothesis. Now, what are we testing? Is this a proportion? Is it a test on average, on mean? That's a nice piece of information right there, isn't it? Or are we testing variances? The answer is we're testing the mean. So the null hypothesis always contains the parameter and the equality. So we're going to do mu equals, and mu is something else. Well, notice how it reads. The average garbage households household uses. Wow. Uses. Wait, average uses is, that makes no sense, but you know what I'm getting at. Is less than 30 pounds. So I know for a fact that the alternative hypothesis, because this is less than and doesn't contain an equality, is mu is less than 30 pounds. Now, what is the complement of less than 30 pounds? It's greater than or equal to 30 pounds, but we really don't care about the greater than part. We really just want to test whether it equals 30 pounds or not. It's either, notice we draw this sort of line in the sand and we say mu is less than 30 pounds or mu is equal to 30 pounds. Now, the sticklers among you might say, well, Ripley, I want to write greater than or equal to. And you would be right, because now we've got a truly binary situation. I'm either less than 30 pounds or I'm greater than or equal to 30 pounds. But sometimes, most often, you'll see this simplified as just equals. Don't panic when you do that, okay? Let me read you another one. The human body temperature is 98.6 degrees. Human body temp. So somebody comes up and says, hey, the human body temperature is 98.6 degrees Fahrenheit. That's a claim. It may or may not be right. Well, what are we testing? What claim are we testing? Are we testing a claim about a proportion, about a variance, about a mean? Well, clearly, I mean, if you really think about this, human body temps are going to be all over the place, right? I mean, take your own temp 6 different times a day, and you're going to find out that your temperature, your body temperature varies depending on what you're doing, depending on the temperature of the room, depending on whether or not you're sick, et cetera, right? So really what we're doing is we're testing an average. All right, now let's see how this guy plays out. The human body temperature is 98.6 degrees. So we're making a statement about the parameter mu. All right? I believe that the average body temperature is 98.6 degrees. So what is the alternative? Notice I didn't make any sort of claim about being greater than or less than or anything like that. I simply said human body temperature is 98.6 degrees. Well, that implies that the alternative hypothesis, which always contains the inequality, right? Less than, not equal to, this guy's going to be not equal to 98.6 degrees. You see how that works? All right, let me give you one more. Excuse me. How about this? Polygraph results are correct more than 80% of the time. Polygraph, so you know, lie detector tests, right? Polygraph results are accurate more than, now hopefully your spidey sense is starting to tingle here, more than 80% of the time. All right, so we have a null hypothesis which contains the equality. We have the alternative hypothesis which contains the inequality and doesn't have an equal sign in it, right? What are we testing? What is this? Is it a mean? Is it a variance? Is it a proportion? Yeah, it's a proportion. It's a percentage, isn't it? So I'm testing this guy over here. So I come back over here and let's see, I'm going to have a P here and a P here. I know the jokes write themselves, quiet. Now look at this. Accurate more than 80% of the time. That doesn't have an equality in it. That's a strict greater than. Okay? So it's going to be P is, my alternative hypothesis is P is greater than 0.8. Well, what's my null hypothesis? If I wanted to, I could write this up as simply P equals 0.8. Even though parenthetically speaking, I guess we could think of this as it could be less than or equal to 0.8. And that gives us this nice complementary relationship between our null hypothesis and our alternative hypothesis. You want to get in the habit of reading claims and immediately being able to flop into, okay, what's the null, what's the alternative? And not only doing it in this class, but every time somebody, you know how they say, 56% of all statistics are made up on the site or on the spot, right? That's a claim. You could test that claim. You know what I mean? You could actually go around and grab people randomly and have them quote a statistic and whether or not it was made up or not. Okay? There's lots of fun ways. There's tons of fun ways that you can test claims, and actually we're going to do a bunch of that in this class. But the first thing you have to be able to do is write the null and the alternative hypothesis.